This learning path is an introduction and overview of generative AI. We'll understand what generative AI is all about, we'll get introduced to prompt engineering, and we'll understand what large language models are about. And we will cover some recent advances in generative AI technologies and discuss some concerns, ethical considerations, and pitfalls of generative AI. But first, we have to know what exactly is generative AI. And that's what I will discuss here in this video. Artificial intelligence and machine learning have been the focus of research for many decades, but it's only in the last 10 to 15 years, with the advent of big data technologies and the ability to process massive data sets, that artificial intelligence really came into its own and became a very exciting field. Generative AI is one class of artificial intelligence techniques and models designed to generate content that is both novel and coherent. Generative AI models are usually trained on massive data sets, and they know how to produce content similar to the training data that they were trained on, but not exactly the same. They learn patterns and structures that exist in the training data and can reproduce those at the output. Generative AI models are trained to produce data that resembles or extends from existing data, and this data can be in the form of natural language, text, images, audio, and even video. If you have been a student of machine learning, you know that most machine learning models are trained to make predictions. They are trained on massive quantities of data. They understand structures and patterns in the data, and they use those patterns to make predictions about new instances and they haven't seen before. But generative AI is different in that it can create new content rather than recognize patterns or make predictions. Now, it's quite possible that you have heard the term generative AI only in the last year or so when it became this busy, exciting catchword that everyone is talking about. The recent buzz around generative AI is due to the simplicity of UIs to create high quality text, graphics, and videos in seconds. When we discuss the evaluation of generative AI, you will see that interest and research in this field has been around since the 1950s and really caught steam in the last 10 years or so. It's the recent technologies and the recent advances in models such as OpenAI's ChatGPT and Google's Bard where the excitement moved to another level altogether. Let's get a very high level overview of how generative AI models work. You use a very powerful machine learning model to learn patterns and relationships in a dataset that created by humans. Most generative AI models just train on data from the internet. The data is of course pre-processed and cleaned up, but it's just data that has been put onto real world by all of us. We are constantly generating data and this is the content used to train these generative AI models. A machine learning model is just a mathematical representation that tries to capture the relationships and entities that exist in the real world. So these models used to learn data that was used to train the model to create entirely new content. And the idea is that the new content resembles the content that the model has seen before during the training process. But it's not exactly the same. Let's say you have trained a generative AI model to generate images of cats. The cats that the model will generate will look like cats it's seen in the training data, but it may not be identical to any cat images that originally existed. Before the last couple of years, enormous strides were made in building artificial intelligence and machine learning systems that excel at discriminative modeling. Generative modeling is different. Generative modeling focuses on capturing and modeling the underlying probability distribution of data to generate new samples that resembles the original dataset. When you are training a generative model on data, it's trying to understand the probabilistic and probability distribution of the input. Once it understands the probability distribution, it's able to sample from the probability distribution to generate a new content. Now, you are likely familiar with discriminative models. They work a little differently. Discriminative models also focus on learning statistical patterns and distributions that exist in the data, but their object is to figure out the decision boundary that separate classes or categories within data, allowing those models to classify the input data based on the features. These classifications or categorization is the prediction made by the model. Since discriminative models are the ones that we are used to, the ones that we are familiar with. Let's understand how discriminative modeling works first. Let's say you have a discriminative model is trained on a huge corpus of data. Let's say it's trained on images of handwritten data, and every image is associated with a label indicating what the digit is. The training data usually contains a large number of observations, and every observations will be associated with a label. These observations are the entities the model has to classify in the prediction phase. Every observation, and here let's assume that each observation is an image, is associated with a label or a category. So the model training on this data tries to figure out the characteristics or the patterns of the image that belongs to the various different categories. So the objective of the model is to map the features of the data that it's trained on to the category. So it will figure out this is how 3 looks or this is how 4 looks, and all 1 looks kind of this way. The model thus figures out the relationship that exists between the input images and the corresponding label or category. Once you have a trained model, it's ready for prediction. The trained model then accepts a new observation that is unlabeled or uncharacterized. It should be able to look at the patterns in the new observation and say, you know what, this looks most like the category. The output of this model is usually a probability score associated with each class or category the input could belong to. The category with the highest probability score here, let's say, is 8. That's the predicted label or the prediction from the model. Now that we have understood discriminative models, let's get a high level intuitive understanding of generative model. The objective of a generative model is to understand the statistical patterns and the probability distribution of the input data so that it's able to generate new data which resembles the input data. Once again, with generative models, the training data contains a large number of observations. In order to be able to generate high quality output, the training data has to be massive. The natural language models of today that you see have been trained on billions of records. Generative models has usually trained using unsupervised learning techniques. In that, training data needs not to be labeled. However, the observations in the training data are all of the type of entity that you want the generative model to create or generate. If it's a natural language model, the training data will comprise of natural language text, and if it's an image generation model, the training data should have input images. During the training process, the model learns features of the real data. Meaning, let's say you are training this model on images of cats. The model will try to understand what it is that makes up a cat. Where are the whiskers? Where's the noise? Where the ears look? What posture does the cat use? The model will try to learn the correlations and relationships that exist in the input data to be able to generate new data of its own. Once we have a trained model, the model accepts some kind of input. The input can be in the form of a latent noise variable. The input can be some kind of text. It can be anything. And using the input and the learn features during model training, the model now generates new content that is similar to the original content but not exactly the same. There are a few important details to keep in mind about generative models. The first thing is that they are probabilistic in nature rather than deterministic, which means you can feed in the same input at different points in time, but the probabilistic nature of the generation means you might get a different output each time. You are unlikely to ever get the exact same result, even if you use the same input. This is completely different from how discriminative models work, which tends to be a deterministic. Once you have a model with the same set of model parameters, when you feed in a prediction instance, the deterministic model will output the same result. It will apply the same set of computations to the input and produce the same result, and this is what happens in deterministic modeling such as classification or regression. Unless the model has changed in some way, the same instance should give you the same prediction. However, generative models do not work in this way. They are probabilistic model because they incorporate some kind of random elements during the course of generating the content, and That is what allows them to create a new entities in response to input. You might have noticed that when you ask ChatGPT or Google Bard a question, it will give you similar responses but not exactly the same. That is the probabilistic nature of these generative models. The field of generative model is very exciting, and as you might imagine, generative AI models are harder and are more complex because they need to model more complex relationships that exist in the data. So if you feed an images, it's not just about figuring out, oh, this is an image of cat or this is an image of a dog. If it has to model the image of cat, it has to know exactly how a cat looks, how a cat poses, how a cat sits, how a cat eats, in order to be able to generate new images of cats.